Welcome to This Explainer. Right now, literally at this exact second, a massive wave of human spiritual devotion is moving across the globe, and it's synced perfectly to the dynamic astronomical calculations tracking the sun's daily journey. Every single day, millions of people structure their entire lives around a schedule that isn't dictated by some arbitrary clock on the wall, but by the precise, ever-changing geometry of our solar system. It's absolutely fascinating, and today we're going to unpack exactly how it happens. Here's our roadmap for today. First, we'll look at the daily rhythm. Second, how it's driven by the sun. Third, the shadow rule. And finally, the global calculation methods. Let's kick things off with part 1, the daily rhythm, and those 5 key moments of connection. For practicing Muslim, the day is anchored by 5 distinct milestones: Fajr, Dhuhr, Asr, Maghrib, and Isha. Now, these aren't just moments to pause and reflect, they're absolute cosmic anchors, with each one tethered to a very specific astronomical event. Instead of living by rigid hours and minutes, this rhythm inherently binds your daily routine to the actual physical rotation of the Earth. A midday meeting or an evening dinner is conceptually scheduled around exactly where the planet is in relation to the sun. It's a really profound way to structure human existence, and it's completely distinct from the standardized mechanical grid of modern timekeeping we're also used to. But that brings us to a huge, compelling mystery. Because the Earth is tilted on its axis and constantly orbiting, the sun's path across the sky shifts a little bit every single day, right? The daylight hours stretch out in the summer and they compress down in the winter. So if the sun's path shifts every single day, how in the world does a fixed notification on your smartphone keep up with an ever-changing cosmic clock? Which leaves us perfectly into part 2, driven by the sun and the actual mechanics of solar time. Take the concept of the zenith, for example. The midday prayer, Dhuhr, doesn't just kick off at noon because the clock strikes 12. It triggers at the exact millisecond the sun reaches its highest altitude for your specific coordinates. In fact, true solar noon almost never aligns with 12 p.m. on a standard clock. You see, standard time zones are basically artificially drawn human constructs. They were designed largely for train schedules and global commerce, essentially just averaging out solar time across wide regions. But zenith calculations, they strip away all those human constructs. It is pure celestial mechanics, completely dependent on your precise latitude and longitude on Earth relative to the sun on any given day. The entire day is mathematically sliced up by these solar angles and horizon events. Let's look at Fajr, the morning prayer. It has to be completed before sunrise, beginning at astronomical twilight. This happens specifically when the sun sits exactly 15 to 18 degrees below the horizon. Why that specific angle? Well, because that's the literal mathematical point where the atmospheric scattering of light actually begins to visually illuminate the night sky. Later on, Maghrib is triggered the very moment the sun completely sets. And mirroring the morning, Isha begins when the sky has fully darkened, typically when the sun drops 15 to 18 degrees below the horizon once again. It's just a perfectly symmetrical calculation based entirely on degrees of solar dispersion. Moving right along to part 3, the shadow rule, and how we calculate the afternoon. Now, think about the time before we had atomic clocks, complex algorithms, or GPS devices in our pockets. Measuring a precise 15-degree solar depression was incredibly difficult for the average person. So for Asr, the afternoon prayer, ancient scholars used a brilliant, highly observable physical measurement, the shadow. As the sun lowers past its zenith, shadows naturally stretch and lengthen across the Earth. When a shadow reaches a precise mathematical proportion to the object casting it, boom, the time for Asr has arrived. It's an incredibly elegant analog solution to a complex astronomical problem, requiring absolutely nothing more than a vertical stick and the light of the sun. But what's really fascinating here is the split in regional interpretations. Under the standard convention, which is followed by the Shafi'i, Maliki, and Hanbali schools, Asr is triggered the exact moment an object's shadow equals the object's own height, plus the length of its shadow at noon. But the Hanafi convention applies a mathematically different rule. They actually wait until the shadow is exactly twice the object's height. Because the sun has to drop significantly lower in the sky for a shadow to stretch to double its length, the Hanafi Asr time usually falls about an hour later in the afternoon. So if you've ever wondered why 2 mosques in the exact same city might pray Asr at entirely different times, well, this ancient geometrical divergence is the exact reason why. And that brings us to part 4, global calculation methods and tracking the sun for the entire world. Just think about the sheer computational scale required to manage all of this today. We're talking about modern systems tracking these precise astronomical data points to recalculate daily times for over 10,000 cities across more than 200 countries. Because the sun's position relative to Earth changes depending on your exact latitude, longitude, and elevation, the math can't just be static. It has to be completely recalculated from scratch for every single one of those tens of thousands of locations every single day of the year. It's a massive, silent data operation happening continuously behind the scenes. And because the globe is so vast, a one-size-fits-all algorithm is literally mathematically impossible. Latitude drastically affects how light behaves during twilight, especially the closer you get to the northern and southern poles, where twilight can linger for hours, or where the sun might not even set at all during certain seasons. To maintain extreme regional accuracy and solve for all these geographical quirks, modern platforms synthesize more than 10 different institutional standards. Depending on where you are, a system might auto-select the Muslim World League, the Egyptian General Authority, Al-Qura in Mecca, or Diyanet in Turkey. Each authority has meticulously refined slightly different conventions for those exact solar angle calculations we talked about, ensuring the schedule remains flawlessly accurate to local realities. So when your device pings you for a prayer time in Jakarta, London, or New York, it isn't simply playing a pre-recorded alarm. It's seamlessly functioning as an astronomical observatory right there in your pocket. It's cross-referencing your GPS location and device time zone with highly accurate data of the sun's exact declination today, synthesizing regional juristic conventions like the shadow rule, calculating atmospheric refraction, and delivering an exact, localized, to-the-minute schedule. It's literally doing the math of ancient astronomers in a fraction of a millisecond. To wrap up this explainer, I want to leave you with a final thought. We so often think of our digital devices as artificial barriers, things that disconnect us from the natural world. But in this specific case, the very algorithms running quietly behind the screen of your smartphone are continuously linking your daily life directly to an ancient, cosmic dance between the Earth and the sun. It makes you wonder, if our most personal daily routines are dictated by the precise geometry of the Earth and Sun, how much more connected are we to the celestial clockwork than we realize? Thanks so much for exploring this fascinating topic with me.